Hi, everyone. Good morning, good afternoon, good evening, depending on where you're joining us from. We'll just allow everyone attending an extra 20 to 30 seconds before we get started. Okay, my name is Mike Arsenault, and I'll be your moderator for today's webinar, where we're featuring the premiere of Stantec's second Spark film called Safer Through Science. Now, the runtime of this film is just over 7 minutes, and then we're going to have an in-depth panel discussion about how we can make our communities safer through science. On the panel today are Rick Guthrie, Vice President, Geohazards and Geomorphology, Thad Waskelevitz, Principal, Geohazards and Geomorphology, and Caitlin Oram, Geomorphologist. And we really want this to be an interactive discussion. So if you have a question about what you see in the film, or if you have something to add, or if you're looking for clarification on a point that is made, let us know in the Q&A, and we'll do our best to get you the answer that you're looking for. Now, before we start the film, I'm pleased to welcome Stantec's Chief Operating Officer for North America, Susan Reesboard, to our event today to say a few words. Now, Susan is a part of our executive team at Stantec, a geoscientist by training, and one of the earliest champions of DebrisFlow Predictor as a tool designed to help our communities. Susan?
Thanks, Mike. Hey, please let me add a warm welcome and a hearty thanks for taking time out of your day to join us. I'm very excited about DebrisFlow Predictor. As Mike mentioned, I've been a fan for a long time. I remember the first day that Rick showed me what this model could do, and I got to tell you, I was blown away. I hadn't seen a tool before like this that was this fast, probabilistic, visually intuitive, but most importantly, could provide really site-specific results over an entire region. And, you know, what struck me is like what a difference this tool could make. So it was very easy to become a champion of Rick and our geohazards team. It was easy to become a champion of making DebrisFlow Predictor accessible to more people, to create this bigger platform to make communities safer. So I love DebrisFlow Predictor. I hope you do too. And Mike, let's get into it. Let's watch the video.
Sounds great. Here's the premiere of Safer Through Science.
The winds were really strong. It was extremely dry, extremely hot, and the fire made a really big run. Our old house was located near Sheep Creek. The creek runs through kind of a narrow valley. The winds blew the fire down that narrow valley where our house was located and burned the house down that way. It was absolutely devastating. My sister describes losing the house as losing a person. It was as if the house had its own biography. My family's been connected to this land for 6 generations, almost 130 years. We were camping out in this meadow over here. It had started kind of spitting rain and then it started lightning. We saw water running down the road. We followed it up and realized that Sheep Creek was experiencing a flash flood. And it had completely jumped its banks and was flowing over the foundation of our old house. Sheep Creek is the next watershed below Black Hollow, downstream of Black Hollow. There had been a massive catastrophic debris flow at Black Hollow that pushed 6 homes into the river and killed 4 people.
It was just a normal July rain, nothing unusual about it. It wasn't real heavy. And I looked down and there was about 1.5 foot of mud and water going across the patio. I put on some rubber boots, trudged my way across what was flowing and made my way up the mountain a little ways where I could look at the creek coming down. and was blown away by the creek that's normally a foot deep and 5 feet wide is now 15, 20 feet deep and 25, 30 feet wide. And all this rock and debris is just flowing down, and it's all just black water. As I was making my way up the mountain, I saw Dick Brown's house going down the river. I saw the firefighter, my fellow volunteers. I'm a volunteer firefighter up here. They were driving up and down the canyon trying to figure out, what was going on and where people were. The loss of life and loss of houses and loss of 60 years of my life. I grew up here, and I grew up coming up here, and to see the devastation, not only from the fire but from the flood. It's devastating, and it'll never be back. At least I don't think in my lifetime I'll ever feel like it's back to some normalcy.
When we arrived on scene at Black Hollow event in Poudre Canyon, that was probably one of the most humbling experiences I've had as a scientist, knowing what had happened at the site and that people had actually lost their lives. It really hit home to me the importance of what we're doing and really trying to, get the best possible answers that we can get so that those types of things don't happen in the future. Chaffee County is 4 hours south of Poudre Canyon. We did a pilot project to model and map where post-wildfire debris flows could potentially occur ahead of the wildfire, and then assess what the risk of those debris flows might be to infrastructure and buildings in Chaffee County. Debris flows are very dangerous landslides that start in mountainous topography and run out over long distances. Fire makes the ground hydrophobic or impervious to water. Moderate rainfall can't be absorbed by the soil, so the water stays on the surface, and that can be enough to cause a debris flow. We could help the county in terms of prioritizing which areas are most prone to these types of events, and then helping them develop planning and solutions to deal with those particular hazards. We have the capability to also help, communities find the funding that they need to be able to support that type of mitigation. DebrisFlow Predictor is a two-dimensional modeling software that allows us to model shallow landslides, including debris flows and post-wildfire debris flows. Where is a debris flow most likely to initiate? And then once we understand where those locations are, then we run a very large number of debris flow runout scenarios as the debris flows come out of the watersheds and into valleys. It allows us to look at how that flow might change its location over time, and then we can assign a likelihood of that debris flow occupying a particular space in time that then informs our risk analysis.
This watershed is really important for hundreds of thousands of people, most of whom do not live in the Poudre Canyon. So the flood mitigation work that was done on these tributaries to the Poudre River and the Poudre Canyon not only benefited families like mine and other private landowners, but that work also benefited the users of that water downstream. We also situated our new house in the least hazardous place possible on our land. We have a more realistic understanding of the kinds of geological processes that can occur on this landscape.
I'm happiest when I'm up here. I feel close to just my history. Feel close to the community. We have a pretty close-knit community up here. It's my home. It's always been my home.
Well, I hope you all enjoyed the premiere of Stantec's second Spark film, Safer Through Science. Rick, Thad, and Caitlin are actually joining me now, and I'd like to make first a special mention just to thank Dan and Maya for sharing their stories with us. It was very, very powerful, and I know very emotional for both of them. So just the thanks to both Dan and Maya for sharing their stories with us. For this discussion, I'd like each of you to maybe introduce yourselves and tell us what you do at Stantec. Thad is one of the stars of the film. Let's start with you.
Thanks, Mike. Appreciate it. It was really fun doing this video with the team. At Stantec, I lead the U.S. geohazards and geomorphology team, subject matter expert on flood after fire for Stantec, all the way through from the geomorphology to 2D modeling. Started doing work on post-wildfire in Southern California in around 2006, I think. So have been doing this for a while, and have enjoyed sort of bringing, my skill set to Stantec and working with the team.
Well, it's great to have you aboard, Rick.
Yeah, hi guys. Thanks, Mike. You saw that. So I have the privilege and good fortune of leading and working with a team of really bright folks doing geohazards all over the world. And our focus, for maybe obvious reasons, when you see a video like this, in the last several years has really been on debris flows and post-fire debris flows in particular.
Thank you, Rick. Caitlin?
Hi, thanks, Mike. I'm a geomorphologist on the U.S. Geohazards and Geomorphology team. I work on a variety of geohazards, mostly river systems, hill slopes and landslides, and post-wildfire processes and erosion. I have been doing and thinking about post-wildfire erosion studies since my PhD, and it's by far my favorite subject to have a project within.
Awesome. Well, it's great to have all of you here. And again, I'd just like to remind all of you watching this discussion that we want this to be interactive. So if you have a question or a comment, again, about what Rick, Thad, or Caitlin do in their day-to-day work, or what you saw in the film, or specifically about DebrisFlow Predictor, please let us know. Rick, I'm actually going to give you the first question just to kind of somewhat re-emphasize what we just watched. High level, what exactly are debris flows, and why should people be concerned about them?
Yeah, so I guess at the highest level, debris flows are a class of landslides that travel very quickly in a fluid form, very quickly, very long distances from their source. So I like to say that if you couldn't beat Usain Bolt in a race, you then definitely cannot beat a debris flow, because generally speaking, they're faster. They travel a long distance from their source out into places where we care about. So the communities, highways, infrastructure that tend to develop on areas in, close to, adjacent, or within mountains that are relatively flat. And in those flat areas, they're flat because it's a depositional zone for a debris flow. So, so the hazard presents itself to communities who are often unaware of how bad it could be.
Awesome. Thank you for that. And so Thad, the next question is to you. And I found this very interesting. Dan had actually mentioned this to us during the initial interview we had with him. We just weren't able to fit it into the final runtime of the film. But the Black Hollow area was studied for the potential of debris flows by non-Stantec engineers before the July 2021 event. And the resulting debris flow was well beyond their models. So Thad, can you just tell us what kind of happened there? Where was that disconnect?
Sure. I think, when we look at the event that occurred in 2021, we're still relatively early in the process of understanding debris flow runout modeling. And so I think initially in some of the work that was being done, there were sort of trying to apply, I think, riverine principles to debris flows, which were probably significantly underestimating the potential within these locales for the occurrence of debris flows and where they would potentially run out to, and the volumes of material that would be expected. And so I think as we've been, developing more and more information in this arena, those runout models are becoming, better and better able to predict what those end results might look like.
And I think it bears mentioning. So Thad and I were working on the other watersheds. So we'd been hired to look at adjacent watersheds, and actually, we were up late at night going through our correction factors because it's quite alarming, right? So you have a situation like like Colorado, where the signs of debris flows aren't really obvious. The fires kind of wiped out the sign. Maybe that hasn't. The debris flows do tend to be correlated to fire cycles, and maybe they haven't seen anything for 200 years. And so we were looking at the results in the adjacent watersheds that we were working on, going to people are going to be stressed out by this. This is overlapping with a lot of houses, and we want to be very confident in our calibration settings before we move on. And I don't know what time it was, Thad, but it was late, and we finally went, okay, we're going with this. And at the exact same time that we were determining that, yeah, it's going to make it all the way down and affect these fans, 2 watersheds over, the Black Hollow event was occurring, and Thad remodeled it like the next day, pretty much, when we found out. Hey.
Mm-hmm. Yeah, and we took what we had calibrated for other watersheds and applied it to that location, and we were pretty accurate with DebrisFlow Predictor in terms of seeing that the loss of houses that occurred at that particular site. So
yeah, so the footprint was about the same, and the depths were about the same. We published that in
I think that was
Now, Caitlin, I want to bring you into the discussion now too. In the film, we saw that both Maya and Dan had mentioned that the amount of rainfall before the debris flow wasn't really concerning. They said it was just a small amount of rain, nothing really to be concerned about. And you mentioned that those quotes jumped out to you. Why was that?
Yeah, so I mean, that's a typical response, right? So this debris flow in Black Hollow occurred in July. I think Dan in the video says it was a normal July rain, quote, right? And honestly, in northern Colorado, that it rains in July, we're all celebrating typically, right? And that would be the right response if we were in a pre-wildfire, non-burned type scenario. But when the landscape has burned, when the vegetation has burned away, when the ground has been altered and possibly even become hydrophobic, you can have a very susceptible landscape, right? You can see a lot of erosion very easily. The landscape is very vulnerable, and that kind of dovetails in with debris flows can become incredibly likely, right? We can initiate these debris flows off this kind of vulnerable landscape. And so the whole landscape has dramatically changed, and that therefore the response to such a small amount of rain is going to change as well. So they had the right response, right? But it's something that we have to keep in mind, is that even a small amount of rain can initiate a debris flow in a post-wildfire setting, right? We don't need high intensity rainfall or even moderately intensity rainfall to initiate a debris flow in those types of scenarios. So it's maybe something to keep in mind when we talk about communities and thinking about post-wildfire hazards. The landscape has changed dramatically, but our mindsets might not have changed dramatically yet. And so kind of educating and telling people and thinking about how the landscape has changed and how that response might change may actually change how they respond to even something like a light rain.
And we've seen this play out. We've seen this play out in Colorado. We've seen it play out in California, in British Columbia, every place that we've been doing post-wildfire assessments, and that change can be quite dramatic. I mean, it can be 50 times more debris flows or sometimes hundreds of times more debris flows than the pre-wildfire scenario.
Let's pivot now from Black Hollow to Chaffee County. So Thad, what information did we exactly provide to Chaffee County, and what are some of the challenges that communities of their size, counties of their size, have in utilizing that information?
Sure. So in Chaffee County, we did a pilot project where we actually simulated a wildfire. Caitlin produced that simulation to then inform our debris flow predictor models of where potentially susceptible terrain would be in combination with some other variables. And so in the end, what we were doing was to produce a risk assessment. And so we ran the modeling side of things to look at not only the hazard in space and time, but that run out hazard that's associated with debris flows. And we use that hazard as part of our risk assessment to look at buildings and roads and the likelihood of those building and roads being hit by debris flows to determine what that risk was, both from loss of life as well as from economic hardship was another component that we considered. So, in the process of producing this information, we had both the footprint of the runout of the debris flows, and we also had the risk information that we supplied in a GIS format to the county so that then they could superimpose that over their existing, infrastructure information. And so, we're doing the modeling side of things, but the output of what we're producing is very easily ingested into the community's existing infrastructure. And so in that information, we provided that initially. And so as we were doing this pilot project, we wanted to then interact with the community to figure out exactly, how they were seeing the data, how we might explain a little bit more detail, get their sort of interest in particular areas that they were concerned with, to be able to help them sort of think about how might we prioritize these areas that we perceive to have a high risk, and what other areas might they be concerned with that we may not have considered given their local knowledge and sort of their level of risk tolerances as well. So I think providing that information, the community had sort of a new perspective on what sort of infrastructure and what homes might be impacted as a result of a potential wildfire in this area.
Now, Caitlin, this has been mentioned kind of in the film and during the early part of this discussion, but really the key to this risk analysis is conducting it before the wildfire occurs. Why is that proactive approach so important?
Yeah, so immediately following a wildfire, and honestly, even during a wildfire before full containment, you have the highest likelihood of a post-wildfire hazard occurring, like debris flow. And so that's when the risk is highest to our communities. And after a fire, there are a lot of agencies, a lot of stakeholders on the ground trying to actively manage the situation. But there really isn't a whole lot of time to collect data, to analyze that data, possibly do modeling exercises like DebrisFlow Predictor, and then to take all that data and break it down and transfer that knowledge into the hands of the people who are making the decisions. That's a lot of work. And we have a very short amount of time before a debris flow could possibly occur. So being proactive and having a best estimate of what we could expect in a certain area if a wildfire were to come through. And in this case, we're looking at a potential high severity, so like more of a bad or worst case scenario. To have that data in hand and be able to already share that with the people who are going to be making those decisions ahead of time can really help those communities become more resilient, to bring that data in to inform all of their emergency planning. As Thad mentioned earlier, prioritizing areas that could be a higher risk, and having those conversations early about what are their plans if this was to occur, and what could we do now pre-wildfire to help alleviate or mitigate some of that risk.
Yeah, I think there's something about the preparation. It isn't, so we actually are working with communities immediately post-fire, but to the extent that they are already prepared, they know the kinds of decisions that they are able to make, they know where the resources are located. We're able to often take the information that we've run and rerun it for an affected area more efficiently. I think it is, you in lots of things in life, you go out and life is hazardous. And so let's imagine you're going out for a hike and you run into a bear. If you've never thought, what will I do when I see a bear? Then it's going to be a very uncomfortable encounter. And if you have kind of thought that through, maybe you're carrying bear spray, maybe you've already got a plan about how you're going to work together. It's still maybe a little bit uncomfortable, but you are more likely to produce a good response. And so so this is actually a really computationally friendly tool. We're able to do this work quite efficiently and say we provide an enormous amount of value for the resources that are being protected. But I think that to be able to do it in that calm state of mind when you can imagine the scenarios versus when you're just faced with, I have to get it right because everything is on the line right now, it is certainly advantageous to be out in front of that problem.
Now, Rick, you had mentioned that we've done a lot of work similar to this across different counties in Colorado. So Thad, specifically, I'd like to talk about Grizzly Creek, because I know we did an assessment there. Can you tell us more about that work that was completed?
Sure. So the Grizzly Creek fire is actually fairly similar to what we were modeling in Chaffee County and served as sort of a guidance for us thinking about like how, what are the types of responses that we might see within that system. And so in the Grizzly Creek fire, we did another risk assessment there where we're looking at, what might be the potential impacts to I-70, which is a major, highway through the state of Colorado. What might be the impacts to individuals traveling on this road, as well as what might be the impacts for, a volume of material getting out onto the road, and how much would that actually cost from a removal standpoint. So that information that we gathered, we also looked at how that varied over the recovery of the fire. As well, to see how risk might actually change. And so in our detailed analysis there, we were also, informing which areas would potentially stay at high risk or higher risk for a longer period of time. And when I say higher risk, higher than background levels in that area. So at the end of the day, a lot of the information that we gathered from Grizzly Creek really helped us in the proactive wildfire approach and allowed us to have sort of a methodology that we could follow and, I think relatively easily, complete the project that we did in Chaffee County.
And Ted, one of the things, I feel like in the conversations that we've had, one of the things that you've highlighted a lot that we're getting, after modeling millions and millions and millions of these, that we're getting right is this downslope path. And so if you're thinking of highways, for instance, which long linear infrastructure intersecting lots and lots of hazards along the way, being able to predict with a surprising degree of accuracy, quite precisely where along the highway we're going to need resources in the event that something occurs, and kind of the amount of resources we need. This location, not the location beside it or a kilometer or a mile down the road, like it's really here. And if we're going to have a storm, all your equipment needs to be ready to mobilize to these spots. It's kind of neat to follow that along, eh?
Yeah, I think it is. It's really interesting to see as we've grown in terms of using DebrisFlow Predictor with that methodology. I think one of the areas where DebrisFlow Predictor really excels, because we're able to run, literally thousands of debris flows in various scenarios. By doing that, we sort of think about the idea of, where is that debris flow going to potentially go? And by doing these simulations, we're able to, reduce the spatial uncertainty in terms of where that runout is going to occur, and then therefore allows us to, I think, more accurately pinpoint locations where we will need to come in and assist after the effect or during the storm itself, even. So,
and I think there's a good point of clarification there, and Susan mentioned it at the beginning, but it's the tool is probabilistic. And so we have this belief that a model has to match a debris flow in real life as if the debris flow, if there was only one. And it turns out that, you know, a lot of natural systems, debris flows are what we call self-organized critical systems. And so if I was to initiate a debris flow, let's just imagine at my initiation, it's 2 meters deep, and I let the material go down the slope, and then 3 years later, I do the exact same thing at the exact same location. They will still be different debris flows. In fact, Thad's done a whole bunch of work in Colorado at a place called the Chalk Cliffs, looking at these telescoping bends, and, you know, they're kind of different every time. They're going all the time, and they're all slightly different. And so with a probabilistic tool and running those thousands of debris flows that that's talking about, you can actually see what that variability is, and you can see the paths that it's most likely to take versus the paths that it might just take on 1 out of 1,000 times. So.
So Rick, I think you and I have been developing video content for DebrisFlow Predictor since the end of 2023. And I know millions of debris flows have been used to model DebrisFlow Predictor. So if you can maybe just give us an update of how many millions of debris flows that have been utilized in developing the solution. And also, what have you learned from a sample size that large?
Sure. So when we sort of say, so we're sitting at, when I say we, I mean the Stantec team, because there's some external folks who have done some work as well. So the Stantec team has now modeled about 9 million debris flows. And we should say that's from, just going to make it up, probably from close to 1 million locations, from close to 1 million initiation, or maybe it's actually close to 100,000 initiation locations, not 1 million, 100,000 initiation locations. So what that means is, because it's probabilistic, as I mentioned, we can go across a region and we'll run lots of debris flows multiple times in sort of this Monte Carlo style of analysis. In the process, we're learning things about how hazard accumulates in the runout zone, where, like we've been talking about, the highways and communities and so on. It's not a surprise that it isn't equal. You know, if you live up on a terrace versus if you live close to the river, then up on the terrace is probably safer. But we're actually able to quantify what that hazard looks like, which has been really interesting. One of the things that I'm currently finding fascinating is that you can start to see the mechanics of surge behavior. We get a lot of descriptions of what debris flow surges look like in the literature, but nobody's really, to my knowledge, nobody's explained why they're occurring. And as we're initiating these, we can see the surges and go, oh, it seems likely that it is a mechanistic property of the topography, and makes sense as some portions of the debris flow kind of find a faster path and some find a slightly slower path, and ultimately you end up with these waves that are running through the system, and we can actually watch that. And so there's all sorts of, because it's visually intuitive, because we're able to work with large numbers, there are all sorts of little nuances that we hadn't appreciated before. I'm making a bit of a long-winded answer, but I'm old enough to be using cameras with film, and actually, Mike, you are looking for some pictures that you know, from when I was a kid we were out hiking and with my dad and stuff, and I realized, oh, I have a picture with my dad in it, or I have a picture with where he took it, where I'm in it, but nobody took selfies. That wasn't part of what we did, because if you and actually photos in general were a scarcity. You would take 12 or 24 photos, and then you would take it and they'd get developed over a couple of weeks, and then you would see if they were good or if people's heads or feet were cut off. And then now, like, photographs are so ubiquitous that it like I have more pictures with Thad and Caitlin than I have with my dad in the same photo. And it's because we're always doing it, and we get instant feedback, and we start to look at photography in a different way, and anybody can be a great photographer with a phone. So I think DebrisFlow Predictor is something similar. We go from data scarcity to data abundance. And so then all of a sudden, the kinds of questions that we can ask about debris flows actually starts to change, and the way we perceive solutions changes to, oh yeah, we could do that. We'll just run through a whole bunch of these again, and so we have more options.
Rick, I have to say the mention of Monte Carlo methods brought me back to my undergrad stats classes, and I broke into a cold sweat during that explanation. Caitlin, to you, what can wildfire-prone areas do to build more resilience for their community?
Yeah, so I mean, we're in Colorado, so it's basically almost all the state. So I would say first, if you're in a community that's in a wildfire-prone area, to really understand your wildfire risk. Now, nowadays, most states and local agencies have their own wildfire risk maps. So looking at those and understanding, okay, we're wildfire prone, but how wildfire prone are we? You know, what is the risk involved with this? And then taking that into the community and doing that education so that everyone understands what that means for them and for the larger community, and also starting discussions around that, not only about the wildfire risk, but what are the post-wildfire risks, right? And so with those discussions, we can really, you know, and I think Thad mentioned this earlier, that local knowledge of an area is really important. So those discussions really start to gather that information. You know, maybe there was a wildfire 10 years ago and people have observations about that. Maybe there was a debris flow that happened afterwards that there's not a whole lot of data on, but somebody can tell you, hey, firsthand, that came through my yard, right? Something along those lines. They can also tell you local knowledge about what's important to them. So getting back to that prioritization type of idea, you know, we can come in as an outsider of a community and say, hey, probably your hospitals, your schools, your EMS systems are probably pretty important, your power grids, those types of things. But there might be historical locations, recreational locations, places that are really important to that community that without those discussions, you're not going to understand, and you might not include them in a risk analysis, right? Or take those into account when you're trying to understand the hazard and risk in a post-fire situation. The other thing is kind of gauging in those discussions the risk tolerance. Some people might be very risk adverse, while others are like, yeah, I'm okay with moderate risk, right? You know, like we know there's risk here, it's fine, right? So really that kind of integration and talking with the people in the community, whether that's the community driven or maybe an external consulting group like us coming in and initiating those conversations. And then from that, what I've seen a lot in Colorado are a lot of small programs that are happening in these communities, especially the ones up in the mountains with pretty high wildfire risk, you know, looking at, you know, fuel management along the wildland urban interface, those types of programs. But also there's larger programs that are Colorado state wide. And I know there are similar things in all over the Western US in different states and probably in Canada. But, you know, like the state of Colorado has a Live Wildfire Ready type site that can give you tips and tricks in as a private citizen all the way up through a community or county, what they could be looking at. And so, you know, having those discussions and doing that early planning and, you know, taking that proactive approach really. So what we did in Chaffee County and brought in a whole bunch of data to inform those types of planning activities before a wildfire occurs is really important, because you're going to get your best answer, right? You're going to make your community even that much more resilient and see the benefits of that if unfortunately a wildfire occurs in that area.
And that proactive approach, oh, sorry, Rick, go ahead.
Yeah, I just wanted to highlight a couple things that Caitlin said. So one of the interesting things is that each community has its own unique values. And so we're doing, for example, we're doing work for the Stolo First Nations in BC. We're actually almost finished that work, looking at 6,000 square kilometers of land around the Fraser River. So Stolo First Nations is a group of nations, and so they had, to Caitlin's point, so you know there are the obvious hospitals and emergency management and the travel corridors along the highways that are really important, but they've also identified things that have cultural significance to them that that became part of the detailed risk assessment, and so that'll be unique for each of these communities, but there's really reasonable conversations that we can we can have, and kind of and try and incorporate that information into any analysis that gets completed.
And that proactivity is key as well, especially this time of the year. We're at the end of May, and I'm based in Ontario, Canada, and the forecast is a very severe wildfire season. And we're seeing that really across the continent, that wildfires are becoming more prevalent and more damaging. The season gets longer and longer. So this is really apt for across the continent, really, to kind of take this proactive approach. I want to pivot to DebrisFlow Predictor specifically. Now, there are other pieces of software out there who do somewhat similar things. So I'm curious, Rick and Thad, maybe Thad, we'll start with you. What makes DebrisFlow Predictor a unique offering?
Yeah, I think Rick's kind of highlighted a little bit of this already. The way that the model is designed, we can run a large number of scenarios within the model very quickly. And because the model's not deterministic, we're getting runs that are more probable, or allow us to do things that are more probabilistic instead of just a single event and, here's what we think the potential outcome might be. And so within DebrisFlow Predictor, having that capability to be able to, look at a large number of debris flows initiating potentially in a wide array of places in the watershed, allows us to, I think, do things a little bit differently than some of the traditional softwares that are out there and are, developed, have been developed and continue to be developed at the current time.
And I think there's maybe a couple of other things that bear mentioning. So one of them is DebrisFlow is what we call an agent-based software. And I won't get too much into the technical details there, but the important part is it's both computationally friendly, and it's quite detailed. So we do massive areas. We do it quite quickly, and it produces very helpful granular kind of level results. So spatially, it's about 5 meter by 5 meters. Every pixel within the output has all of the data associated with that 5 meter cell. And then vertically, it's the accuracies or the specificity anyway is at about 0.1 centimeters. Is that right? Or is it centimeter scale? It's centimeter scale, sorry, not 0.1 centimeters, centimeter scale accuracy. So this makes it really easy to do things like update the digital elevation model to try mitigation techniques if we want to build basins or berms or fences, to kind of see, hey, if we're going to do some mitigation here, how effective is it going to be? What are we going to stop? How is it going to redirect debris flows? And so that's also a pretty unique thing. And then the other thing that we actually haven't mentioned, so up till now, we've been doing this all internally, but for some of our partner, particularly government groups or some of our more sophisticated clients who have their own internal geohazard specialists, then they can just get on DebrisFlow Predictor right now and kind of outline their area of interest. There is a paywall, but they can get in and play with it. We have playgrounds so they can start be comfortable with it, and the paywall is really reasonable. So they can outline their area of interest and get working on it themselves too. And so we've got lots and lots of documentation to help people along. So I think the ability to do large areas or small areas with a fair degree of accuracy is another huge benefit.
Well, you mentioned paywall. So Rick, I'm curious, how did you arrive at the pricing? What was the pricing strategy for the solution?
Yeah, so we really have two pricing strategies, but the main one for most folks is a flexible pricing strategy where as you are interested, so we have what's called a pricing tool. If you go to our website, there's a couple of links that can take you right there. But you sort of say, this is my area of interest, and the pricing tool bounds that study area, and it says, hey, the amount for this is whatever the dollar value is. And you find out right away, so you can optimize it if you want to increase your area or decrease your area to optimize kind of the value you're getting. You can do that really, really easily. And then and then you go through what we were, then it takes you into the program once you've paid for that. So we tried to, we've invested lots in developing this, but we realized that if you're protecting one home, for example, or one small section of road, there's not, to pay an expensive tool just doesn't make sense. And so the cost is actually quite low. If you're developing a new community, so we have examples along the Wasatch Mountain Range, for instance, in Utah, and you see people building out communities on these bands. And so as part of that development, they're going to install 50 or 100 houses. Maybe they need to build a basin. And so they need a slightly larger area, but it's still, for the values you're protecting, it's enormous value. And so we tried to kind of arrive at the sweet spot of doing the right thing and being able to provide enough funds to keep moving this forward as a program and to keep developing it. The second thing is for really high-end users, and there's a few of them that would be out there where you'd have multiple users working in the same company. There's an enterprise license. All of that is laid out. You can find all that information from the tool itself. There's a manual. Everything is in there.
That's great. Appreciate that the peek behind the curtain. Now, we've talked a lot about wildfires, obviously with the tenor of the film that we saw, but let's tweak that slightly. So how do post-fire debris flows differ from debris flows that are not fire related, and how can DebrisFlow Predictor kind of manage those differences? Let's hear from Thad.
Sure. So I think when we, as a scientist on this side, I think, one of the things that we think about with these post-wildfire debris flows is obviously considering the hydrophobic conditions, you get a lot of runoff within the system. And so one of the typical types of debris flows that you get is a runoff-induced debris flow following a wildfire. And in this process, what you're seeing is as that flow works its way down through the system, it's building the sediment volume that it has and eventually converting over to a debris flow. And so I think it was mentioned in the movie as well, how a big wall of debris, was moving down through the system. That's a result of this sort of bulking of material as the water moves down through the watershed and starts to pick up that sediment. And part of the reason why you see the big changes in the channel, as was mentioned earlier in the film, is a result of that material being continuously eroded as you're working down through the watershed. As the field has sort of grown a little bit more, we've also seen that there are transitions, maybe from these runoff generated debris flow events to where we get more infiltration as that hydrophobicity breaks down and as material starts to erode away. As we move out in the recovery of the wildfire process, we start to see shallow landslides occur where the soil is actually becoming inundated with water, and that poor water pressure causes a shallow landslide that then, as it moves down through the river network, it actually starts to build and tumble and build more material to pick up and start a debris flow within these areas. So you get a shallow landslide that very quickly changes over to a debris flow within these environments. And so, some of the current science related to understanding these differences in the types of debris flow, has been looking a lot at sort of the soil's ability to absorb water. And what's been found is that ability changes over the recovery of the wildfire. And so we might see a transition from that runoff dominated to an infiltration dominated or an infiltration initiated debris flow event occurring, within that watershed. And so traditionally, if the area is not burned, you'll have something that behaves more like that infiltration initiated debris flow in that area as opposed to the runoff dominated, because you have more vegetation, you have more organic material within the soils, a lot of things that create roughness factors that slow down that water from entering into the system. And so traditionally you'll see more of those infiltration induced debris flows in non-wildfire environments. So I think those are the differences that you see, but there's kind of a gray line because you can have both things occurring within wildfire prone areas or areas that have experienced recent wildfires.
And so one of the things that we do in every watershed, every time we go in, there's a calibration step. And so the model works on some fundamental underlying principles of debris flows, but there's a calibration step which allows us to adapt to either the local physiography or the local ground conditions. And to Thad's point, we're doing some work in Scotland right now, and if you've ever been to Scotland in a rainstorm, like water is coming off from everything, and we're finding that those debris flows there tend to behave a little bit more like the post-wildfire debris flows. Our calibration settings are closer to our post-wildfire debris flows because so much water is accessible. It's closer to this kind of breakthrough style.
Well, we're nearing the end of the webinar, so I really want to get deep into the physics. I've been waiting for this question, wanted to make sure we're all warmed up before I ask this one. So can DebrisFlow Predictor model non-Newtonian flow, for example, like a tailings dam failure?
It's not really. So the short answer is no. It may be by accident, but not properly. Like getting the right answer in a math test that you couldn't show the work for because it wasn't correct. There are really good models available for that kind of stuff. So HEC-RAS, in particularly in North America, we're using all the time. In Europe, it's more often it's something like Mike 21, but there are great models to do that. So we're not trying to replace those models. So we want to differentiate between what we would call gravity-driven, sediment-laden kind of flows going down a slope, and hydraulically driven, sediment-laden flows going through a river. And so there's some overlap. And I think we provide in our manuals and in the FAQs in the program, we provide pretty good guidance to help distinguish between whether you're in this situation or that situation. But we're trying to kind of stay in our lane and do a really great job of debris flows, which we think we do better than anybody else, and not replace great working models that are already in existence.
Awesome. Now, our final question is going to be a bit of a lightning round. So we're looking for approximately 30 seconds for each answer, and it's for all three of you. And I'm hoping that it can act as somewhat of a recap of sorts. So in your mind, what should be the biggest takeaway from the film and this discussion? Caitlin, let's start with you.
Oh, I get to go first. That's great. I would say the major takeaway, especially having done the Chaffee County work, is really taking that proactive approach. They're doing that in the wildfire space, modeling and simulating wildfires, but it's kind of a new idea, I think, in the post-wildfire hazard space and debris flow space. And so I just see a lot of value. And, when we worked with Chaffee County, they saw the value in that as well to really help them understand and the risk and the hazards that could occur. And work that into their planning. I think that's probably the most important takeaway from the work that I've done as part of this.
Awesome. Thanks, Caitlin. Thad?
Sure. I think to follow up on Caitlin's premise there, I think from my perspective, I'd much rather be working in a proactive scenario than a reactive scenario because of the pressure cooker that's associated with that reactive scenario. Not that we, don't work in those environments, but I think the proactive component allows us to get in and interact with the communities and to try and, I think, get information to them about what potentially might happen, as well as get their inputs, which I think helps us in the end kind of produce a deliverable to the client in a more meaningful way. So in some way, shape, or form, we're kind of educating each other on, what's happening within the local community and what the potential is for that hazard, and allowing them to just make better and more informed decisions.
Awesome. Thank you. And Rick, last word to you.
Yeah, so I think there's two things. So the first one is that the problem is solvable. So we like solving really difficult things. And I think we've now got some technology that makes difficult problems regionally or at a site-specific, in a site-specific example, solvable. Whether we do it, whether you do it in-house, whether our competitors are using DebrisFlow Predictor to do it, it is a solvable, tractable problem. And the second one is it is a lot less expensive than you'd expect to kind of go through the whole process, and the value you get for it in terms of lives, infrastructure, communities is irreplaceable. And so I think it's just making some kind of commitment to getting out there and trying to solve these problems.
Awesome. Great capper. Thank you, Rick. I'll even let it slide that I asked for one takeaway, you gave us two, but that's fine.
Okay.
Thank you to all three of you, all of our panelists, and thanks to all of you for joining this discussion. We're actually going to be bringing you 2 more Spark films about the human impact of innovation later on this year. Our next film features innovative air quality monitoring technology in the United Kingdom. So stay tuned for details. Have yourselves a great day, and I hope you'll join us next time.
Thanks a lot for everybody showing up.
Thanks, everyone.